Hello, welcome to lesson 3.2. What we're going to do today is go over the lesson that we would have had in class. And so you should be following along in your notes and writing all these things down. To get started, just like we would in a normal class, we are going to start with a bell ringer. So go ahead and do these two problems in your notes and tell me what you get when you're done. But go ahead and pause the video and work on these two problems. All right, so for the first one, remember we're using order of operations, so PEMDAS. So I'm going to look at simplifying my parentheses first. And so I've got a set of parentheses right here, and I need to simplify what's in there. And it's kind of like I'm going to apply the order of operations, like again, within the parentheses. I'm going to say, what do I do first? Do I do 4 squared first, or do I do 4 plus 5 first? I'm going to take care of this 4 squared. So I'm going to have 35 minus, and this would give me 16, because remember 4 squared means 4 times 4. It's not 4 times 2. Plus 5. Now I can add those together, and I get 35 minus 21, and that will give me 14. Ran out of space there. But my final answer should be 14. For the second one, still using order of operations, the first thing I'm going to take care of is this exponent. So I'm going to get 3 to the third power. This means 3 times 3 times 3, and that's going to give me 27. Everything else stays exactly the same. Now, according to the order of operations, I don't have any parentheses or exponents now, but I do have multiplication or division, so I'm going to take care of that. And I'm going to get 27 minus, and I'm going to get a decimal, and that's okay. If I divide 7 by 4, I'm going to get 1.75. So then, when I do my subtraction and I do 27 minus 1.75, I'm going to get 25.25. Now I said do that without using a calculator, and so that might have been a little tricky, but that's okay. I just wanted you to see the process here. And a mistake a lot of people will make is that they do 27 minus 7 first instead of doing the divide first. And so they get, 20 divided by 4, which is 5. And that's wrong. That does not give us the same answer. And so that's why it's super important to follow the order of operations. All right, today we're going to look at scientific notation. Scientific notation, a number in scientific notation is written as the product. What does the word product mean? It means multiply of 2 factors. So one of your factors is greater than or equal to 1 and less than 10. And the other is a power of 10. So in other words, it's some number between 1 and 10. It can be exactly equal to 1, but it cannot be exactly equal to 10. It has to be a 1-digit number. So 9.9 would be okay, but 10.0 would not. Whereas over here, we can use 1.0. We just can't have anything less than that. So 1.0 would be fine, 0.9 would not. And so the other is going to be a power of 10. What does the word power mean? It means what we're going to raise like 10 to some number here. That's not a 0. That's saying like a number goes in here. I guess I could put an X instead. So for example, we have sometimes really big numbers, especially in like science, when we're talking about mass and volume and all those things. And so what I'm going to do here is rewrite this as 7.5 times 10 to the 12. Well, hopefully we can see I get this 7.5 from my first 2 whole numbers. And then it's always going to be a 10. There's always a 10 here and always the times. But where does this 12 come from? This 12 comes from how many spaces do I have to move my current decimal point to get in between the 7 and the 5. And if I count, I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have to move it 12 times to get there. So we're going to practice converting between scientific notation and standard. This one over here is what is called standard. And then we'll also do the other way, going from standard to scientific notation. So the mass of the sun is 1.989 times 10 to the 30th kilograms. Rewrite this number in standard form. So what I'm going to do is I'm going to start by writing 1.989, and it's times 10 to the 30th. So this 30 means that I have to move my decimal place. If it starts in scientific notation, I'm moving it to the right. So I'm going to move to the right 30 spaces, and that's a lot, so bear with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Whew. Now, what do you think I'm going to do with all of those spaces where there's no numbers? I'm going to fill them in with zeros. It's going to take me a second because all of this one just has a lot of zeros after it. And to be honest, I don't even know what this number would be called. I know like million, billion, trillion, but I don't even know what number this is. But if we wanted to put in our commas like every 3, remember doing that where you would say, okay, there's 3, 3, 3. Ooh, that's a big number. So like here's thousands, here's millions, here's billions, here's trillions. I have no idea beyond that. So here's my question. Why do you think we use scientific notation when we're looking at things like the mass of the sun? Why is scientific notation a good thing to use? It's a good thing to use because who wants to write this number out where we can't even pronounce that? I can't, at least. If you can figure it out, let me know. But it's not always practical to write a number out like this. And so scientific notation lets us write it like this. And we can say, wow, that means I have 1.989, but I'm moving my decimal 30 spaces to the right. That's a big number. And scientific notation is helpful in that sense. But now we're going to go the opposite way. So the mass of the Earth is this number. And again, I can't say that. But we need to write it in scientific notation. So what I do when I start with standard notation is I put a box around any number that, or like all my numbers until I get to like the start of all the zeros. So in this case, 5 and then 9, 8. And the decimal has to go after the first number because it has to be a number between 1 and 10. I cannot have 59.8 or 598.0 or 0.598. Nope, it's got to be 5.98. And now I'm going to look at this and say, okay, how many spaces or how many places do I have to move the decimal point to get from here to in between the 5 and the 9? So let's count. I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So since I move it 24 spaces, I'm going to write this as times 10. It's always going to be times 10, 24. Why do you think it's times 10? What does multiplying by 10 mean? If you think about it, if we do 3 times 10, that's 30. So basically, I just moved that decimal place 1 to the right. Anytime I multiply by 10, I'm moving the decimal place. And so it's saying move the decimal place. This is saying move the decimal place 24 times. And so that's why we always have multiplied it by 10. All right, so try this one in your notes and then let me know what you get and then check your answer with what I have after this. So if I have 1.3 times 10 to the fourth, I'm taking 1.3 and I'm moving my decimal place. That's what the 10 means. I'm moving it 4 places to the right. So I'm going to move this 1, 2, 3, 4. And fill in all those spaces with zeros. So my answer would be 13,000. The population was 13,000. And that one's not too bad to write in standard form. But I just, again, want to give us some practice with seeing how do we convert between the two. All right, try this one on your own and then come back and see what you get. All right, so I'm going to put a box around all my numbers. Even though there's a 0 right here, there's a 9 after it. So I'm going to go ahead and include that 0 with my box. And I'm going to get 2.909. Now, to get from where the decimal is now at the end of the problem to in between the 2 and the first 9, I have to move my decimal 1, 2, 3, 4, 5, 6, 7, 8 spaces. So I'm going to write times 10 to the 8th power. And there you have it. This is how we're going to write things in scientific notation and in standard form. It's something that hopefully is a good little review for you. And it'll pop up as we go through. But if you have any questions about this, make a note in your notes and we'll talk about it together in class tomorrow. Thanks, guys. Have a good day.